Greetings and welcome to Pinball Help. Mike here. Work is continuing on this Bram Stoker's Dracula. This is the system driver board. I pulled it out of the machine. If you watched the previous episode, we had discovered that somebody had soldered some connectors. I had to loosen those. That was for these guys over here. So in the game we tested and we found out that something was wrong in the 20-volt circuit. So there's not a whole lot going on there, so it's pretty easy to troubleshoot. When I pulled the board, I tested the bridge rectifier, and the bridge rectifier was out. I'm going to do a separate video on how to test these bridge rectifiers, so you know how to do that. But I just wanted to give you an update on what I've done with this game. I replaced the bridge rectifier. I also replaced the cap that it was going to. And I'm debating on whether or not I want to start, replacing any of the other caps. But everything seems to be okay. But I wanted to mess with that circuit since it's been refurbished. I also replaced C4 here. This is a part of the 5-volt thing. It makes it run a little bit smoother. I may mess with a few others, but I found that the solder on this particular board is really hard to liquefy and pull out. So it's a tough one. I had to struggle with it a little bit, but I managed to get everything taken out. So I've got a new cap, new bridge rectifier, and everything tests okay. I'm going to end up making some connectors for these things so that I don't have to solder those things back the way the previous person did it, so it'll be better than before. This is the reverse of the board, and you can see a little bit dark there from that voltage regulator. I'm going to cut the leads off of the new bridge rectifier that I put in, and this should be good to go. I also reflowed the pins over here that had the things connected to them, because for all I know it might have been a bad solder joint, and that's why the guy just bypassed it or whatever. So I've reflowed the header pins here so that when I redo the connectors I won't have to worry about this being a point of failure. So this board is probably ready to go. But I'm going to do a video on, and the next video in the series is going to be on testing for bridge rectifiers, so you can see. I also wanted to bring up something. In the previous video I talked about this this resistor here and how it seemed like it was shorted out or didn't have a register. Well, I looked it up in the schematics and it's 0.13 ohms, 10 watts. And I was like, what is that doing there? Because it's not even really doing much of anything. I asked around, and what I was told is that this is the 20-volt circuit is also what powers the flashers, and there needs to be a little bit of resistance on that to limit the amount of energy that flows into these cold flash bulbs when they're initially energized, because they'll create a whole bunch of RF interference and some other issues. So this resistor right here sits in the circuit and just dampens a little bit of the energy rush that flows through when they need to power up those flash lamps when they're cold. So that's what it is. It's basically an open circuit, but this puts a little bit of resistance in the circuit, which I think helps and reduces the radio frequency interference and probably helps with the flash bulbs. So that's why that's there, even though technically speaking it doesn't have a ton of resistance. So there you have it. I think when we put this thing back in, everything should work. You'll see I marked when I did these things on the components, so anybody else that comes in can see, okay, these were done in January of 2020. And so there you have it. Now I'm going to also do a video on checking bridge rectifiers. So that'll be my next video. It'll just be kind of an independent thing. But for more, visit pinballhelp.com. Please subscribe. I've got a Twitter thing. And that's it. Thanks for watching. Hopefully this thing's going to work real soon.